Hello, everyone. This is the continuation of our discussion of the experimental research strategy. And in this second part of our discussion, we are going to talk about ways to control extraneous variables. We're also going to talk about manipulation checks as well as increasing generalizability of our experiment results. So let us start. Let's begin by talking about controlling extraneous variables. And if you remember our previous discussion, we talked about independent, dependent, and extraneous variables. When we say independent variables, these are the variables that you manipulate in order for you to produce several treatments or levels in your experiment. It allows you to come up with multiple groups, while the dependent variable is the resulting variable or what you measure, what you observe. However, regardless how careful we are in designing our experiment, there will always be what we call extraneous variables or variables that we are not interested in the first place, but they somehow affect the result of our experiment. Now, there are three standard methods for controlling extraneous variables. Two methods involve actively intervening to control the variables by holding the variable constant or by matching values across treatment conditions. While the third method is randomization and it's more passive compared to the first two that we're going to talk about today. Okay, the first method in controlling an extraneous variable is known as holding a variable constant. So what does it mean to hold a variable constant? By standardizing the environment and procedures, most environmental variables can be held constant. Basically, the opposite of a variable is a constant or something that shouldn't change. And we know that in real life, there are a lot of extraneous variables because we all have our own environment, we have our own values, we are in different situations. But in an experiment, we can try to make your situation and your environment constant by making the environment the same for everyone. So all individuals in the experiment can be observed in the same room at the same time of the day by the same researcher. So let me give you this example. What if you are interested in the willingness to study mathematics among children? And then some of your participants participated in the morning, while some of your participants participated in the afternoon. We can guess that if we're dealing with children, then they are less likely to be interested in the afternoon. One way to address that is for you just to hold the experiment at the same time of the day, and that should be in the morning. Regardless how many days you do that experiment, as long as you do it in the morning, then you are holding that variable constant, making use of the same room, having the same researchers. If there's a male researcher administering the experiment, then it would be ideal if the same researcher would administer the experiment to everyone. When I attended a convention back in 2018, I recall that there is an excellent presenter. He shared his experiment to us. It's about our tendency to hire someone, and his manipulation is the skin color and the surname of the person. Is it Filipino or Chinese? And then he was emphasizing in his presentation that the resume that he printed as a manipulation was printed using the same printer at the same day at the same time. Hence, he made sure that there will be no extraneous variables, okay, to the best of his knowledge. And he found out in his experiment that we are more likely to hire people who have lighter skin, and there's a preference towards people with Chinese surname than Filipino surname. People who are most likely to be hired in that experiment are those individuals who are light skinned and at the same time they have a Chinese surname, while people who are least likely to be hired are those with Filipino surnames at the same time they also have dark skin. And so he was able to establish cause and effect by being very careful in his experiment. That's what we call standardization. We're making sure that we're administering the same procedure to everyone. Okay, we cannot be biased towards someone. We cannot be more kind to a certain participant, but we are cold towards another participant because that's no longer standard. Instead of establishing a cause and effect relationship, then other variables will somehow change the flow of your experiment, and it will also influence your findings. Another way to eliminate the effects of extraneous variables is by matching. Here's an example of matching. A researcher using two samples of college students could assign 20 younger students under age 25 and 10 older students to each separate treatment condition. So what do we mean by that? We cannot, here's an example of groupings that is not done carefully. One group is composed of older individuals and the other group is composed by younger individuals. However, you are not trying to manipulate their age. It just happened that one group was composed of older individuals and the other was composed of younger individuals. That can be a factor that may affect your results, especially if you're not even interested with age after all. This researcher tried to address the problem with age by trying to distribute the ages of the participants across the two treatment conditions. So he put a limit. He says that I can only have 20 young participants in group A and 10 young participants in group A. The same with group B, I can only have 20 young participants and 10 older participants, so that the composition of group A is at least similar to group B. So that's matching. Will you be able to do that if you do your experiment? I guess it's easy to say, but it's something that's very hard to achieve. So here's another example. A study using two different rooms could match the rooms across treatment conditions by measuring half of the participants in one room and the other half in the other room for every treatment condition. So that's another way to do matching. So this time, the matching was not with the nature was not with the profile of the participant, but with the design or the environment where you conducted the experiment. So you made sure that the environment or the laboratory you're using are very similar to each other. Now, here's another way of doing matching, and this time we're going to talk about counterbalancing, but we're going to have more about counterbalancing in another lecture. Before I begin, take note that in this example, I am not going to talk about two separate groups, but rather the example I'm going to be using will only utilize one group. So in this hypothetical study, we recruited 20 students, and then we want to know which book is better, book 1 or book 2, so that we will know which of the two books should we endorse to the students who are going to enroll to our course. So what we did is this. We asked these 20 students to read book 1, and by the end of the week, they have to take an exam. And then after 1 week, we asked them to read book 2, finish it, and they have to take another exam. What's the problem with that design? When you take the second exam, we cannot really say that your score in the second exam is only the product of reading book 2. It can also be influenced by the first book. At the same time, it can also be influenced by the first exam. Especially if you use the same exam, then you may have a higher score after reading book 2. But it doesn't necessarily mean that book 2 is better. So how do we do counterbalancing? We can try to switch things up by doing it this way. For participant number 1, what I'm going to do is this. First, you're going to have to read book 1, and then after 1 week, you read book 2. But in my case, as the second participant, you will ask me to read book 2 first before book 1. So in layman's term, we are changing the order of the manipulation from one participant to another so that the changes in scores is not due to the order, but rather it's due to the manipulation. And we will have another example when we discuss counterbalancing in another lecture. Here's the third way of controlling. For extraneous variables, you can also do randomization. Randomization is the use of random process to help avoid a systematic relationship between two variables. The goal of randomization is to disrupt any systematic relation between extraneous variables and the independent variable, thereby preventing the extraneous variable from becoming confounding variables. Here's one example scenario that calls for randomization. What if you're interested in mathematical ability, and because you're a lazy researcher, you just ask one section to participate in your study, but you didn't know that that section is the star section, or in other words, the students in that section, they're all gifted. You don't want that kind of extraneous variable to influence your research results. So that mistake would have been avoided if you did randomization, meaning you got your participants from different sources. Okay, for example, if we want to know student ability in mathematics, then we can get students from different sections so that we don't only survey or we don't only get data from one group of participants, because a group of participants participants may have a common characteristic that we are not aware of. Random assignment is the use of random process to assign participants into treatment conditions. Other than being random in selecting your participants, you can also be random in assigning them into groups. Okay? For example, you are a participant. I cannot just put you in one group because I like you to be in that group, but rather I should randomly assign you. And one way to do that is, for example, I only have two groups. I can toss a coin and determine if you will be in group A or group B. For example, if the research schedule requires some observation in the morning and some in the afternoon, a random process can be used to assign treatment conditions to the different times. So after tossing the coin, I will determine if I am going to ask you to come in the morning or to come in the afternoon. However, there's one downside in relying on tossing a coin. If you toss a coin 10 times, there's a chance that you will get more heads than tails. What if you get 7 heads and 3 tails? Then it means that one group will have 7 participants and the other will only have 3. Okay, so randomization is a passive way to control for extraneous variables. And although it tries to control extraneous variables, it's not a guarantee that there will be no extraneous variables in your study. Still, randomization should not be abandoned just because of its shortcoming. In order for you to understand what I've been talking about since earlier, let us look at this visual aid for you to know how do these different ways of controlling differ in comparison to each other. So first, let's look at column A in a confounded treatment, meaning this treatment did not apply any type of control. Perhaps a beginner was doing this, and this is commonly seen in studies conducted by undergraduate students. Now let's look at this. Look at treatments 1 and 2 under column A. Is it unfair? Yes. Why? There are more high IQ individuals in treatment 2 than in treatment 1. So if we're going to compare mathematical ability, treatment 2 will appear to be better than treatment 1, not because the manipulation is better, but because the students in that group are better. So let's apply some control. In column B, look at there are still two treatments, but we're trying to hold the variables constant. So what we did is that we only selected participants with low IQ so that all of them would be equal. There will be no other characteristics, and that's what we call holding it constant. We also have what we call matching. Letter C made use of matching, and in these two treatments, look at this. If there's a high IQ individual in group 1, there's also a high IQ individual in group 2. If there are 4 high IQ individuals in group 1, there's also 4 in group 2. We make sure that the number of participants with a common characteristic in group 1 matches the number of participants with that characteristic in group 2, so that group 1 is equal to group 2 before any manipulation will be administered. In randomized method, look at this. We randomize the people we're going to assign to group 1 and group 2. However, it still doesn't assure that group 1 is similar or the same to group 2, because even though we randomize, there's a chance to assign high IQ individuals to one group over the other. Now let's talk about the advantages and disadvantages of controlling. So the two active methods of control, holding constant and matching, requires some extra effort and extra measurement. For example, in holding constant, you will only get people with low IQ to participate in your treatment. Then, in order for you to do that, you need to measure their IQ first. Even though IQ is not really a part of your study, you have to exert some effort in measuring their IQ. Other than that, in addition, holding a variable constant has the disadvantage of limiting generalization or external validity. What if, for example, in your research, you only got people with low IQ to participate? However, in real life, they don't only interact with people with low IQ, they interact with all types of individuals. Hence, what is true in the lab may not be true in real life, because what happened in the lab is different in what's happening in real life. And lastly, randomization is not guaranteed to be successful. Chance is trusted to balance the variables across different treatments. Okay, so even though we do randomization, there's always a chance that extraneous variables will continually influence our research results. Now let's talk about having a control condition in your study. And what is a control condition? An experiment always involves comparison. The experimental strategy requires comparing observations of the dependent variable across different levels of independent variable. For example, how are we going to know if there's a difference between 2 doses and 1 dose of a medicine? Then let's have a group that will take greater amount of medicine and one group will take a lesser amount of that medicine in order for us to know that higher doses result to greater effect. So in an experiment, the experimental condition is the condition in which the treatment is administered, and the control condition is the condition in which the treatment is not administered. So one group will receive a vaccine and the other group will not receive a vaccine. And the group that received the vaccine is called the experimental group, while the control group is the group that did not receive any type of manipulation. There are two types of control conditions. A no treatment control condition is a condition in which participants do not receive the treatment being evaluated. And what they do is that they provide a baseline of normal behavior or a standard. For example, like what I told you earlier, the group that did not receive that vaccine, they will show you what would be the characteristic of the participants that did not receive any treatment. And you can compare their condition to the condition of those who receive a vaccine in order for you to determine if there are improvements in the condition after administering the manipulation. It's hard to do that if you don't have a control group. How can you claim that your vaccine is working? That's why clinical trials take a really long time. Okay, because you have to secure a lot of participants and you have to secure a lot of documentation for you to prove that what you're doing is ethical. Here's another type of control condition. We can also have a placebo. So what is a placebo? A placebo is an inert or innocuous medication, or in layman's term, a fake medical treatment such as sugar pill or a water injection that by itself has absolutely no medical effect but produces a positive or helpful effect simply because an individual expects or believes it will happen. If you have a placebo condition, you have a group wherein you make them think that they are receiving the same treatment that the other group is receiving, but in their case, that treatment is not really effective. However, because they believe that they're taking a medicine, they might convince themselves that they are actually getting better, and that's what we call the placebo effect. The placebo effect occurs simply because the individual thinks that the medication is effective. So you don't want your medicine to be placebo. You want it to be really effective. There's a problem in your research if the condition of the treatment group is the same as the condition of the placebo group, because you cannot claim that your medicine is really working. Your conclusion will be the effect of the treatment is not physical but rather it's psychological. The mere fact that you convince them that they're being treated is the reason why they're feeling better. The opposite of the placebo effect is the nocebo effect, and in the nocebo effect, it happens with an inert substance that produces a negative or harmful effect simply because an individual expects or believes that it will happen. So you feel bad after taking a certain substance just because you think that certain substance will make you feel bad or will make you feel worse. And ideally, the placebo group should be equal to the no treatment control group, because if you're going to look at it, the condition of the no treatment control group and the placebo group are similar. The only difference is that the placebo group is taking a fake medication. Their condition after the manipulation should be the same. They're not really taking any medication that has proven to be working. Also, we can make use of what we call manipulation checks. And when we say manipulation checks, in an experiment, a researcher always manipulates the independent variable, and you want to make sure that your manipulation works. Although this manipulation and its results are obvious to the researcher, occasionally there is a question about how the manipulation is perceived by the participant. For example, I remember when I was in undergrad, my very first experiment is about gratitude, and then I told my professor that we're going to have a gratitude group and a neutral group. They will not receive any thank you. And then our professor asked, how are you going to make sure that the participants feel the gratitude condition? So a manipulation check is an additional measure to assess how the participants perceived and interpreted the manipulation and or to assess the direct effect of the manipulation. Take note, the manipulation check is not the dependent variable, but rather this is just your way of knowing if your independent variable manipulation is really working. Suppose, for example, a researcher wants to examine the effects of mood on performance. The study involves manipulating people's mood. Okay, so the mood is the independent variable. So the researcher may induce a mood, for example, anger, and to make sure that it works, we can measure the level of anger of the participant. And on the other hand, the group that was not exposed to the condition that induces anger should not be angry. And that's how you know that your manipulation works. Here are some ways to deliver your manipulation checks. Some of them may be written while some of them may be asked orally. So look at this. Did you notice that the lights were dimmed after the first 15 minutes? Did you notice any change in the lights during the experiment? Or how did the researcher respond when you failed or completed the task? Because there are two conditions, encouragement and discouragement condition. When you log in on Facebook, usually there's a question, did you notice any advertisement about this product? Because they're not sure if their advertisement is really working, they need to ask people if this advertisement was noticed during the day it was posted. So now, let's talk about when to use manipulation checks. So here are 4 instances to make use of manipulation checks. The first one is we use it when we do participant manipulation. So for example, a researcher who wanted to examine the effects of frustration on task performance might try to induce a feeling of frustration by giving one group of participants a series of impossible tasks to perform. To determine whether the participants actually are frustrated, the researcher might include a measure of frustration as a manipulation check, similar to my example earlier about anger. Other manipulation is not so obvious, so a manipulation can also be subtle. So this happens when you only have minor changes, for example, in the way that you smile or not to the participant or in the instruction, and this may not be that noticeable. You want to make use of manipulation check to know if your participants notice this very slight change. Okay, so manipulation check is a must, especially if you're using subtle manipulation. Other than that, you can also make use of manipulations in the placebo group. But before we proceed, I want you to know that if you are part of a placebo group, you should believe that the placebo is real. Meaning you should be convinced that the medicine you're taking is real. Because if you know that you're in the placebo group, then that will influence the results of this experiment. They will no longer take your study seriously. Okay, so in other words, they must have no suspicion that they are being deceived. Also, a manipulation check is important in simulation. And when we say simulation, a simulation research is wherein a researcher attempts to create a real world environment in the laboratory. So the effectiveness of the simulation depends on the participant's perception and acceptance. For example, in your laboratory, you want to make it look like a house. So you're going to ask them if they feel at home in your laboratory. Okay, and that's how you check the manipulation in simulation. So speaking of simulation, let's talk more about that. We're going to talk about increasing generalizability, or in technical terms, the external validity of our study. A simulation is the creation of conditions within an experiment that simulate or closely duplicate the natural environment in which the behaviors being examined would normally occur. Under simulation, we have what we call mundane realism, which refers to the superficial, usually physical characteristic of the simulation, which probably have little positive effects on external validity. For example, like what I told you, if I want you to feel like you're at home in my experiment, then I'm going to put a sofa in my laboratory, as well as we can put some tables or a television. Then that refers to mundane realism. However, if this is not well done, then your participants may find it funny. Hence, it would affect the flow of your experiment. Okay, so it's hard to achieve mundane realism in your experiment. Here's one example of a simulation, the Stanford prison experiment. So the intent of this research was to study the development of interpersonal dynamics and relationships between guards and inmates in a prison. So in their study, they had a sample of 24 normal, mature, and emotionally stable male college students, and then they split them into two groups, 12 guards and 12 inmates. However, as the experiment goes on, they become absorbed in their roles and they begin to interact in a negative, hostile, and dehumanizing and interpersonal manner to the point that they have to stop the experiment before it gets worse. You know what happened? When the experiment was stopped, the guards felt that they were being frustrated because they want to stay in power. And when the experiment was stopped, then they're no longer in power. Okay, so this is one good topic to talk about again when you get to social psychology. Other than that, we can also increase the generalizability of a study by doing a field study. A field study is a research conducted in a place that a participant or the subject perceives as a natural environment. For example, instead of doing it in the laboratory, then let's just do it outside the laboratory. Okay, but at this point, I know that you're already aware that extraneous variables may affect our conclusion. So now let's just look at some examples. Brown and colleagues conducted a field experiment examining how nutrition information affected the vending machine purchases on a student university campus. And they did that by counting the number of healthy and unhealthy food purchased in a vending machine. And they noticed that after the manipulation, more college students are buying healthy products over unhealthy ones. Okay, so that's one way to do an experiment. However, you know that extraneous variables may affect this experiment, especially if even before the experiments, they really prefer healthy goods over unhealthy ones because that's part of their values as students in that school. We just don't know. Okay, there might be other things that we need to consider. So now let's talk about the disadvantages and advantages of controlling. So when you control, there's an increased chance that the experimental result accurately reflect natural events, particularly in simulation. However, the disadvantage of this procedure is that it allows it allows real world environment to intrude on an experiment, which means that the researcher often loses control over the situation. At the end of the day, no matter how realistic the simulation, if the participants know that it is only an experiment and they know that their behaviors are being observed, then they're not going to act in a way that is natural. Okay, so those are the things that we need to remember about controlling. So I hope that you learned a lot about the nature of experimental research. And this is just the first part of a multiple part discussion in doing an experiment. So next time, let's try to look at different ways to conduct experiment, and we can talk about between groups and within groups design. And we can also talk about non-experimental ways of data gathering. So that is it for this discussion, and I hope you learned a lot.